This is one of my linear algebras videos, and I will try to explain you today how to find if a vector is in subspace. I mean a vector space, if it is in subspace or not. So first of all, what is subspace? A subspace is simply a set of vectors with the property that linear combinations of these vectors remain in the set. I mean, like suppose if you take V as a collection of non-empty vectors in Rn, then this V is a subspace if A and B are scalars and vector U and V are in V. And the linear combination should be also in the V, in the vector V. So that is the definition basically of subspace. Now there are a few tests we can do to identify if a vector V is in a subspace or not in Rn. So like in other words, we can say that a set of V is the subspace of Rn if the scalar value of the like A and B are in the V. So there are a couple of tests we can do to make it more simple to understand. For example, like if you take this test, like if there is if 0, suppose the V is the vector, right? If 0 is in the V, test 2, if U and V is in a V, then U plus V should be in the V. And then if U is in the V, and if you take a constant K, which is also in the real numbers, and K U should be also in V, okay, or KV should be also in the V, then it is a subspace. So another test we can do, which is like if V, vector V is a set of solutions to homogeneous linear equations, then V vector is the subspace. We can do another test, which is if V is the span of some vectors then V is a subspace. So these are the theorems, these are the definition and theorems to identify if a vector is the subspace or not. Now, we'll do some examples to better explain and for your better understanding. Let's take example 1. We need to know if x, y, z are in 3-dimensional, then is x plus 2y equals to 3z a subspace? So we need to find out if this is a subspace, right? Now, how to do that? We can just modify that equation, which is x plus 2y minus 3z equals to 0, right? Now, it is a subset. The reason is because it is a solution to homogeneous linear equation, right? Now take another example. How about this? If this is in the space, then ABC, is it a subspace or not? Here we need to test those 3 conditions here. Okay, so let's see if it satisfies these 3 conditions. So our first condition is if 0 is in the vector itself. So this equation, this ABC is greater than 0, that means, or equal to 0, so that means 0 is one of them. So we can say it satisfies condition A, right? The reason is if A equals to B equals to C is equals to 0, that means it is satisfying that condition according to the given expression. Now, how about the condition B? You can see that we say that if UV is in the vector, then U plus V should be also in the vector. So it also satisfied this condition because if A plus B plus C or A plus B or C plus A is greater than 0, right? Now how about C, right? If U is in the V and if you take a constant K, then we are saying it needs to be the product of the constant and the U, or product of the constant of V, should be also in the vector V. Now, does it satisfy this equation? No, it does not. Why? It does not satisfy. See, because like you can take K and A, B, C, which might be 0, but if K is negative, like if K is negative, then A, B, C is not greater than 0, right? So it is since it does not satisfy the third condition, even though it satisfied first two conditions, A and B, but it doesn't satisfy the third one, so this is not a subspace. Okay, now let's take another example. Okay, so the example is, suppose we take you have 0, alpha, and alpha plus 1, and alpha is the real numbers or integers, right? Is it the subspace? So let's apply condition 1 or rule 1. The condition 1, according to condition 1 or A, condition A, we have 0, 0, 0 equals to 0 alpha, alpha plus 1, right? So you have 0 to 0, which is fine, 0 to alpha, alpha, and another 0 alpha plus 1, right? So if alpha, that means alpha is negative 1, right? So alpha is, you see, you have the alpha 0, right? And alpha minus 1, which cannot be true. Like alpha same is 0 and alpha is again negative 1, which cannot be true. So it has no solution. Right? Okay, so this is how we can identify, like, if it is in the subspace or not, because this 0, 0, 0 is not in the set, and the set is not a subspace. Let's take another example. A 1, 0, minus 2 plus B, which means these are the vectors 5, 5, 7. If it is that, then is A, B, is real numbers, and if it is a subspace or not. Now you see these two vectors are actually the linear combination, right? And if it is a linear combination, so I'm saying these two are a linear combination. Like you can find some number of A, B to get these vectors solved. So if it is a linear combination, 1, 0, minus 2 and 5, 5, 7 are the span of A, B, so it is a subspace according to this condition. So if V is the span of some vectors, then V is a subspace. So since it is a linear combination, so it is a span, and that means it is a subspace. We don't have to just test those three conditions like we did in the previous examples. This is another way to identify if it is a vector is in the subspace. Now we can do another example. For example, 5 if K, M, and N are in the 3-space vector, and K squared is N squared, if it is a subspace or not. So let's test the condition 1. So we are saying the 0 should be in the vector. Now, if K is 0, right, we're saying K is squared is equals to N squared. So it satisfies condition A, because K squared is N squared. So if I take 0 as a K, N is also 0. Okay. Now, does it satisfy the condition B? Condition B, which is U and V is in a V and U plus V should be in the V. Let's test it. For condition B, let's take K equals to 1, M equals to 1, and N equals to -1. So in that case, K plus N is 0, which satisfies, right? But if you take K minus N, that gives you 2. So this 2 square cannot be equals to the 0 square. So it does not satisfy condition B. How about condition C? For condition C, let's take a value C as K. So we have CK, CM, and Cn, right? We know that K squared is N squared given. Now C squared plus into K squared will be C squared N squared. So we have CK whole squared equals to Cn whole squared, right? So that means it is satisfying. It satisfied the condition. But even though it satisfies condition A, it satisfies condition C, but it does not satisfy condition B. That the reason this vector is it is not a subspace. So I gave you some couple of examples to identify if the vector is in the subspace or not, and this is how, if you can just do some practice works, you'll know more, and you'll know, like you'll be more skilled to identify if a vector is in if a vector space is in the subspace or not. I hope that will be helpful for you. Thank you very much.